In this video, we'll discuss even and odd functions. A function f is even if for every x in its domain, negative x is also in the domain, and f of negative x is equal f of x. This means that the outputs for x and negative x are the same. For the graph, it means that if the point x and y is on the graph, then negative x and y is also on the graph. The points x and y and negative x and y are symmetric with respect to y-axis, and that means that the graph of an even function is going to be symmetric with respect to the y-axis. If this is my point x and y, then the point symmetric with respect to y-axis will be on the other side of y-axis, the same distance from the y-axis, and this is the point negative x and y. If I choose another point, for example, if the point 3, 0 is on a graph, then the point negative 3, 0 is on the graph. If I choose the point negative 1 and 1 on the graph, then the point 1 and 1 is going to be on the graph, and therefore the graph of such function could be something like this. The graph is clearly symmetric with respect to y-axis. This is an even function. Now, a function f is odd if for every x in its domain, negative x is also in its domain, and f of negative x is equal negative f of x. So the output at negative x is opposite or negative of the output at x. That means that if xy is on the graph of the function, then negative x, negative y is also on the graph. So if this is the point x and y, then the point negative x, negative y is going to be over here. And the points x and y and negative x, comma negative y, those points are symmetric with respect to origin, which means that if we join them with the line passing through the origin, the distance from the origin of each point is going to be the same. So for odd function, the graph is going to be symmetric with respect to origin. For example, we can graph something like this. This graph is symmetric with respect to origin. This is an odd function. Obviously, we can draw many functions, many graphs. Some of them might be symmetric with respect to y-axis, some of them might be symmetric with respect to origin, but there are many that will not be symmetric with respect to y-axis, nor with respect to origin. For example, if I draw the graph like this, there is no symmetry with respect to y-axis, no symmetry with respect to origin. This function, therefore, is neither odd nor even. And there are, you can say, more functions that are neither odd nor even than odd and even functions.